So I'm on this ECMAScript website where I'm just trying to search for hoisting. This is language specification, so I'm expecting they have specified what hoisting is. And what happens is I will keep on getting this one word over and over again. This hoistable declaration. I don't see any definition. I don't see any other information regarding hoisting than this word. So I go to the weird engine source code. So here we have 2-3 pages, whatever search results it has regarding hoisting. But while I was going through them, none of them were quite convincing. As we talk so much about JavaScript hoisting, it is asked in every interview probably. And if you know hoisting, some of you are considered advanced developer, like we have celebrated hoisting a lot. But you don't get that much data when you go inside of the specification and the code. So why is that? And what exactly is hoisting? We need to find out. If you want to learn a new thing, usually these are the 3 places you would go. First thing, the YouTube, the Udemy courses, and the blogs and articles. Usually that is the upper layer of the learning. If you want to go a little bit deep, you'll probably go to MDN or the official documentation. And the last one is basically the actual source code, which no one goes. But that is the single source of truth, and that is the problem. Whatever CV on the upper layer, it just highlights of what the actual concept is, while that source code itself is basically poorly communicated to this top layer that we talked about. You might know that the functions are cached. Why? Because they are reused. But the JavaScript for loops are also cached. These things you will not find on any blogs, this thing you will not find on any YouTube videos, but it is available in the source code for you to see. So that's my point. These things are not communicated to us, and that's what we are going to change. Now we just don't want to understand hoisting. We want to understand other internal stuff as well, like closure, the event loop, the wrapper object, the prototype. So what is the best way to learn this concept? Like, why not just build it? And that's what I did. But before we go to our own version of JavaScript, let's look at hoisting through 3 levels. Level 1, basically just going to the internet and trying to find what they say about hoisting. The one thing that keeps on popping up, moving all declarations to the top. Again, move to the top. Again, move to the top. Moving of variables. What they're trying to say is that this is just one complete variable declaration plus assignment. This is the declaration. This is the assignment. This declarations that you have, and they will be moved to the top, not the assignment part. Hoisted code, normal code. So now when we try to access the value of this variable, we will get, and instead of var, if you just change this to, let's say let, the value is actually not given. These are basically sent to something called as temporal dead zone. If you try to access them, it will turn into an error. So this is called as declaration hoisting. And hoisting is also done for the functions. So here this function as well will be moved to the top. I can basically invoke it anytime. So this is where it kind of makes sense. Okay, I can actually use my functions before declaring them. So that's a good feature. But in case of var, that looks like a bug. By the way, this kind of function hoisting, it's called as value hoisting because your actual value JavaScript is aware when it actually hoist function definition. But in case of variables, it doesn't hoist the value, it hoists only the declaration part. Now, why is that? Why variables are treated differently and the functions are treated differently? While at the end of the day, function is just a variable holding a piece of code. So to dig more into that, we'll go to the level 2. And here we can clearly see they mention these 2 types of hoisting, value hoisting and declaration hoisting that we talked about. But we don't get any documentation regarding why this thing was introduced. I have this book, JavaScript, the first 20 years. And if I search for hoisting here, how many results? 5 to 6 pages are talking about hoisting. Here in this particular paragraph, you can clearly see what JavaScript 1.2 version did was, it allowed the nested function to work. This basically local level hoisting was not possible in JavaScript version 1.0. But again, that's the only reference I could find about hoisting. I still could not find why it was implemented, why it actually exists in JavaScript. After going through all this multiple levels, we kind of just know about how it looks, but we don't know how it works and more importantly why it exists. And that's the reason why I cloned JavaScript, to actually get into the shoes of JavaScript language creator, because at one point they might have found this need, okay, to implement these certain things, I need to have this feature which they have named hoisting. So this is our JavaScript clone. I call it parallel.js. On the left hand side we have our parallel.js. On the right hand side we have our regular JavaScript. The only difference is the console.log are basically replaced with the print statement. Everything else remains the same. This is the output produced by parallel.js for the same code. This is the output produced by JavaScript for the same code. What I realized while working on this thing is that for JavaScript to actually work, it goes through 2 phases. One phase is creation phase and another phase is execution phase. But why? It's the reason why people rehearse. It is the reason why I'm recording this video second time. It is the reason why event manager first plan the event and then they execute, because planning makes way for better execution. It's better when you go through one thing twice, and JavaScript creator thought the same thing, so I did the same thing as well. To do the planning, V8 engine needs to scan the code, then it needs to tokenize it like this, and then it needs to convert into more meaningful form called as abstract syntax tree. Now these are the language internals, and I will not get into how programming language is created, but once this process is done, JavaScript gets a young understanding of the code, and this understanding reflects in the creation phase memory. Here you can see stack memory is aware about all the variables present in our JavaScript code. In the creation phase, it just gives it a placeholder value called as undefined. It does not take that extra step to go and find its value, but for the function, as you can see, it actually goes that extra mile to find the value and store it inside the heap memory. It's a common misconception between JavaScript developers that stack memory holds numbers, strings, values. No, it only holds addresses. And as soon as it sees this say hello function, it goes to the memory and figures out, does it hold any reference to it? Does it know its actual value? And yes, it does. So JavaScript just goes ahead and executes the function. If we try to print array even before it is declared, it actually gives it undefined. Why? Because it goes to the memory, finds, does it know the value of array? It actually does not, but it holds a placeholder called as undefined, so it returns that. For let and cons, those things are not hoisted, so you don't get this either undefined or value, you just directly get an error, just like you get in any other programming language. Now because these two things are working, it kind of gives us the impression that this function was somehow moved to the top, because that is the only way that this function would actually work. This primary awareness that JavaScript have because of the creation phase, it allows code like this to work, which is a design principle which we called hoisting. JavaScript is actually kind of cheating. It's like even before the exam start, JavaScript has already seen the question paper. So it already knows what to do in the exam when it comes. So this creation phase and execution phase, I like to call it as planning phase or preparation phase, and then the execution phase. So if you have seen that marathon video where people just pass the baton, like one guy runs and runs and runs. Let's see if you can find that video. Yeah, this stuff, this is what I mean. So this guy who is falling is basically creation phase, and the guy, who messed up his execution phase. Now it kind of became apparent why this style was chosen, because it just allows you to have better control over your language. And remember, JavaScript was created by one person, Brandon Ike. If it was another person, if you were creating it, probably you would have thought it differently, but that did not happen. The JavaScript we have is the JavaScript we have, and this is the way JavaScript is actually implemented, the creation phase and the execution phase. Going through your code 2 times is definitely performance heavy thing, like it will ask you for few more milliseconds. So there are solid reasons for this two-phase process. First thing is the organization of the code. You don't have to worry about where your function calls, or even if you keep it on the top, and you can again, kind of arrange. So it gives you that flexibility. Second important benefit is the closure support. If you understand this code where we have outer function and it has one variable outer var and one function declared inside of it, which is returning that function itself. So basically, whenever we go to line number 11, that outer function will be invoked and this return value will be stored inside myClosure. Now, myClosure is basically this function. So whenever it gets executed, it needs the value of this outer var. But guess what? The way functions work in JavaScript is that whenever a function gets invoked, its execution context is completely destroyed. That means the variables and the data inside of it, it's completely gone except the return value, which we are already storing in myClosure. So if I run this code, this outer var should basically not work because this variable just does not exist anymore. But it actually works. And look at this myClosure function closely. You can see this scopes property. It is part of this 3 scopes script and the global, of course, but it also has a closure scope with whom the outer function. If I open it up, you can clearly see this outer var is somehow preserved even though this outer function is destroyed, which it should be because of line number 11. So JavaScript in the creation phase itself, it can track down this thing so that when the time comes to execute closure and basically manage the scopes like this for the closure especially, it can do it effortlessly. again, as I said, creation phase helps in a better planning, and it does help plan closures. Another thing that we can have is error checking. So if you are not typing a proper syntax, it can basically, mitigate it in the creation phase itself. Like as soon as you try to run the code, boom, you get an error. Another benefit is memory management. Imagine like you're planning an event and you know how many people are going to come to that event. Helps in planning the chair allocation better. Because of this creation phase, it has now a better chance of doing a memory allocation because it knows beforehand what variables that it need to store in the memory. We get it now that hoisting is more like a design principle rather than just a feature or a bug, but how you can think better about JavaScript because of this thing. So first thing first, just try to use variables declare with let and call. They are not hoisted the way we talk about variables. So as we talked about, it kind of checks that attendance, that what variables are present, so that we are actually in touch with the memory. But in case of let and call, they are just not talking to the memory itself. So you don't have to take that step and actually try to get that undefined value and show you on the screen. So there is no memory involved when you're talking about let and call. Second important thing you should know as a developer is that these are variable expressions and they are not hoisted. Now see, they are like combination of variable and a function, but still they are not hoisted. If I try to access this C on the top side, it will just say that C is not a function. But if I convert this function into a function declaration like this, it will work because it is hoisted. So function expression are not hoisted, function declaration are. Remember, you don't need hoisting all the time. Only if you are thinking that, oh, I need to execute my functions even before that declare, that's when you would use this function. But if you think that there is no need for it in my code, why ask JavaScript to do that extra effort of implementing hoisting? You can reduce that workload from JavaScript by just defining function like this. Be a little easy on JavaScript from the next time. One more thing that you can do is basically just help JavaScript do the hoisting better. You can just declare all the variables by yourself at the top and take the assignments later on. It is hoisting friendly. You are more like walking alongside the JavaScript architecture, kind of just helping it, in parsing, interpreting, and compiling the code that you're. We can do at least that much for JavaScript. And also, see, the time when JavaScript was created and any language that is newly created, it needs adoption from the people. So if you have a cool feature like this where you are saying that, oh, my language, you can actually declare a function later and you can execute it before. Maybe, it help in early adoption of the language. Cool. Thank you.